Hi again, everyone. Today's lecture, we are going to talk about the differentiation of logarithmic function. And the definition of logarithmic function that we encountered in our previous lecture was based always on exponents. So I already provided you the magical mantra when we are solving for the logs. The logs is equals to exponent, just like that. And the properties of logarithms were then proved from that corresponding properties of exponents. So in this section, we will consider the derivatives of the natural logarithmic function denoted by Ln, as well as the derivative of logarithmic function to base a, or the what we call common logarithm. So let us take a glance on the theorem of the derivative of logarithmic function. So we have here on the first column the common logarithm. So we have log base a of x, and the generic or basic derivative for finding log base a of x is 1 over x ln of a. And later on, I will introduce to you what are these theorems. Alright, so let's just take a look now at the other one. Let's first focus on the top part of the equation. So in this second column, we have d over dx ln of x is equals to 1 over x. So this is our basic theorem for the derivative of an natural logarithm. Okay, and this bottom equation that we have, the d over dx log base a of u is equals to 1 over ln a times u times du over dx. This is the chain rule for finding the common logarithmic functions. And the other one, which is the d over dx, or finding derivative of ln of u is our function, that will be 1 over u times du over dx. du over dx means we need to find the derivative of our function, okay, or the u itself. Usually we are getting the derivative of the function inside the parenthesis or the bracket, like that. So this bottom theorem that we have here illustrated is the chain rule for finding derivative of the common logarithm and the natural logarithm. Take note of this. And before we move forward to those illustrative example that we have here in line, I would like you to remember these properties again. So I would like to introduce to you this again. I know that you already encountered this on our previous lecture about logarithmic function. But I would like to refresh in your mind our properties of logarithm, wherein we have m and n that are positive real numbers, b not equal to 1, and p is a real number. So if ever we have the sum of a logarithm, it is equals to the product of a logarithm. That's the clue. Alright, and when we encountered a difference of a logarithm, we can be able to transform it into the quotient of a logarithm. And once we have the log base b of m raised to p, our exponent p here will become constant p. Okay, so p times log base b of m. And for the last property, we have log base b of m is equals to log base b of n if and only if m is equals to n. So make sure you are familiar already with the properties of logarithm, because you can be able to use this in order to arrive to the correct answer when you are differentiating a logarithmic function. So let us take a look and discuss our first example here. We need to find the derivative of f of x is equals to d over dx log base 3 of 5x. So of course we can be able to get the derivative by using this guide or this theorem, the d over dx log base a of u is equals to 1 over ln a times u, then times du over dx. Means we need also to get the derivative of the u or the function itself. It's very clear that our u is 5x. And then what will be our du over dx? So let us take a look. Just plugging in our a here in our given example is 3 base which is the base 3, and our u is 5x. So just plugging in all of these values and our derivative. So we have f prime of x is equals to 1 over 5x ln of 3 times d over dx of 5x, meaning in order to get the du over dx, we need to get the derivative of 5x. And what is the derivative of 5x? That is 5. So that's why we have right now the equation f prime of x is equals to 1 over 5x times ln of 3 times 5. So we can be able to distribute this two numerators, 1 times 5. So we can be able to get this equation 5 over 5x times ln of 3. And we can simplify this by canceling those constant of 5 in the numerator and in the denominator. So our resulting final answer for our derivative of log base 3 of 5x is 1 over x times ln of 3. Alright, so let's move forward to our second example. Find the derivative of d over dx ln of 2x. So it's very clear that our u is 2x and we need to get the d over dx as well, because our theorem looks like this. When we have the ln of u, our derivative will be 1 over u times du over dx. So just plugging in the 2x in our u, and then we will get the 1 over 2x times the derivative of 2x. And what is the derivative of 2x? That will be 2. Okay, and then multiply both of the numerator that we have. So 1 times 2 is 2. And we can get 2 over 2x. Just simplify, cancel this 2 in the numerator and the denominator. We can have this final answer. The derivative for ln of 2x is 1 over x. Okay, so let us see the third example that we have. Find the derivative of d over dx ln of 2x squared plus 1. So it may be look complicated right now, but nothing to worry. Just apply the theorem. Use the correct theorem. Since we have the natural logarithm here, our theorem will be the d over dx ln of u is equals to 1 over u times du over dx. And very clear that our u is 2x squared plus 1. And we need also to get the derivative of 2x squared plus 1 to get the du over dx. So it will become 1 over 2x squared plus 1 times the derivative of 2x squared plus 1. And what is the derivative of 2x squared plus 1? That is 4x. So right now we have the derivative for finding ln of 2x squared plus 1 is 1 over 2x squared plus 1 times 4x. So again, we can multiply these two, and then we can be able to get this. Our final answer for the derivative of ln of 2x squared plus 1 is 4x over 2x squared plus 1. Alright. So let us add a more challenging example. So we have here, we need to differentiate this f of x is equals to ln of the quantity 2x plus 1 cubed over 3x minus 1 to the fourth power. First thing in mind, we need to apply the properties of logarithm. Since we have the quotient of a logarithm, we can be able to change and transform this into the difference of a logarithm. So we have f of x is equals to ln of 2x plus 1 cubed minus ln of 3x minus 1 to the fourth power. And since we have our exponent 3 and exponent 4, we can also use the third property of logarithm. So we can transform this exponent to a constant. So just put our constant at the beginning of our ln. It will look like f of x is equals to 3 ln of 2x plus 1 minus 4. Okay, our 4 here came from the exponent 4 on our previous equation. Okay, so times ln of 3x minus 1. And we are going to begin differentiating this equation. Right? So in differentiating, of course, since we have natural logarithm, we can be able to use the chain rule here. D over dx of ln of u is equals to 1 over u times du over dx. So we need also to get the derivative of the term inside our parentheses. So it will look like our constant 3, or f prime of x is equals to our constant 3 times the 1 over u, that will be 1 over 2x plus 1, and then times du over dx, that will be, we need to find the derivative of 2x plus 1, and then minus our constant 4 times 1 over u, which is 1 over 3x minus 1, then our du over dx, we need to find the derivative of 3x minus 1. So from here, we need to get first the derivative of 2x plus 1 and the derivative of 3x minus 1. Okay, so this 2. And what is the derivative for 2x plus 1? That will be 2. And the derivative for 3x minus 1 is 3. That's why we have this equation, f prime of x is equals to 3 times 1 over 2x plus 1 times 2 minus 4 times 1 over 3x minus 1 times 3. Okay, so first thing that we have, we need to multiply this, and our equation will become 3 times 1 times 2 is 2 over 2x plus 1 minus 4. 1 times 3 is 3 over 3x minus 1. And then multiply again all our numerators. We have 3 times 2 is 6. And then 4 times 3 is 12. So right now, we have here the resulting equation of f prime of x is equals to 6 over 2x plus 1 minus 12 over 3x minus 1. And we need to get the difference of these two terms. Since we don't have a common denominator here, we need to multiply those two denominators. So our denominator will become 2x plus 1 times 3x minus 1. And then 2x plus 1 times 3x minus 1 divided by 2x plus 1 is 3x minus 1. That's why we have 6 times 3x minus 1. And then 2x plus 1 times 3x minus 1 divided by 3x minus 1, we have the resulting quotient of 2x plus 1. And then we need to multiply to our numerator, which is 12. That's why we have minus 12 times 2x plus 1 here in our numerator. And then distribute the 6 to our 3x minus 1, and then distribute negative 12 to 2x plus 1. So we have 6 times 3x is 18x minus 6 times negative 1 is negative 6. That's why it become 18x minus 6. And then negative 12 times 2x is negative 24x. Negative 12 times 1 is negative 12. So right now our equation is f of prime of x is equals to 18x minus 6 minus 24x minus 12. So, of course, combine like terms here. 18x minus 24x is negative 6x. And then negative 6 minus 12 is negative 18. So instead of writing negative 6x minus 18, we can just write it down as if it like this to make it simpler, right? So our final answer for getting the derivative or for differentiating f of x is equals to ln of 2x plus 1 cubed over 3x minus 1 to the 4th power is negative 6 times x plus 3 all over the quantity 2x plus 1 times the quantity 3x minus 1. Okay. Alright, so let's move forward to the last example that we have. Differentiate y is equals to ln of the square root of 1 plus sine x over 1 minus sine x. Since we have the radical form of equation here, we need to transform this into exponential form. And when we need to change this into exponential form, it will become y is equals to ln of 1 plus sine x over 1 minus sine x raised to 1/2. And from here, we can be able to use the second property of logarithm. When we have the quotient of the logarithm, we can change it into the difference of a logarithm. Right, so apply the properties and it will become y is equals to 1/2 times ln of 1 plus sine x minus ln of 1 minus sine x. And we can distribute this 1/2 to both of these terms here. So it will become y is equals to 1/2 times ln of 1 plus sine x minus 1/2 times ln of 1 minus sine x. And from here, we are going to start on our getting derivative or differentiating this equation. So of course, since we have the natural logarithm, we can use as well again. If ever we have ln of u, it will become 1 over u times du over dx. So we're just going to get the derivative of the term inside the parentheses to get the d over dx. Okay? And yeah, so we're going to start the differentiating. So we have y prime is equals to the 1/2, which is our constant, and multiply by the derivative of ln of 1 plus sine x is 1 over 1 plus sine x times the derivative of 1 plus sine x. Then minus the constant 1/2 again times the derivative for ln of 1 minus sine x is 1 over 1 minus sine x times the derivative of 1 minus sine x. Alright, and what are the derivative for 1 plus sine x and 1 minus sine x? since we already have the one, so it is you already know that when we have the constant, when we get the derivative of it, it will be automatically 0. So just focus on the sine x, positive sine x, and the negative sine x. Okay, so the derivative for your positive sine x is cosine x, and the derivative for our negative sine x is negative cosine x. So we have y prime is equals to 1/2 times the quantity 1 over 1 plus sine x times cosine x. Cosine x is our z over the x. And then minus 1/2 times the quantity 1 over 1 minus sine x times the negative cosine x. And again, our du over dx here in our expression is the negative cosine x. And next thing that we need to do is we need to simplify, right? And just move, since we have the same constant here, 1/2. Let us move it at the beginning of our expression and then just combine those terms. So it will become, we have y prime is equals to 1/2 times the cosine x. Why it become cosine x? Because we multiply 1 times cosine x. And then we multiply 1 to negative cosine x is negative cosine x. And since we have the negative sign here, just negative cosine x times negative is positive cosine x. That's why we have an operation of plus sign here. Okay, let's remove those. So right now our equation will become y prime is equals to 1/2 times the quantity cosine x over 1 plus sine x plus cosine x over 1 minus sine x. And then just combine these terms, just like when you are just getting the sum of a fraction. So again, since we don't have the common denominator, just multiply those two denominators that we have. So our denominator will become the quantity 1 minus sine x times 1 plus sine x, or 1 plus sine x times 1 minus sine x. So use this. Okay, 1 plus sine x times 1 minus sine x divided by 1 plus sine x is equals to 1 minus sine x. And then this 1 minus sine x multiply to our numerator cosine x, we will get this cosine x minus cosine x sine x. Then plus, again use this denominator, 1 plus sine x times 1 minus sine x divided by 1 minus sine x is 1 plus sine x. And then 1 plus sine x multiplied by cosine x here, we will get this cosine x plus cosine x sine x. And since we have two positive and negative cosine x sine x here, then we can just cancel this. Okay, we are now beginning to simplify the equation, and we will going to get 1/2 times 2 cosine x. We just combine 2 cosine x's here from our previous equation. That's why we have 2 cosine x over 1 minus sine squared x. So we already get the product of this denominator. That's why we have 1 minus sine squared x. And as you can see, focused on 1 minus sine squared x, we can be able to change it because there is an identity. And what is that? That is the Pythagorean identity. And also from this equation, we can make it simpler. Simplify by just canceling those constants of 2 on the numerator and in the denominator. Just cancel this. And then by the use of Pythagorean identity, from 1 minus sine squared x, it will become cosine squared x. So right now, our equation will be y prime is equals to cosine x over cosine squared x. And then again, we can be able to simplify it by canceling this since we have the same kind of term. And then our equation right now is y prime is equals to 1 over cosine x. This is not the end because we can be able to use the identity again. Right? So the identity for 1 over cosine x is secant x. So our final answer for getting the derivative of y is equals to ln of the square root of 1 plus sine x over 1 minus sine x is secant x. Okay, so this is the end of our discussion. Thank you so much, and I hope that you've learned a lot. God bless you all.